Hello, I am Dr. Chris Hughes, a lecturer in computer science from Salford University. I'm white, average build, with short grey hair, and today I'm wearing a green t-shirt.
And my name is Marta Brescia. I am a pre-doctoral researcher at the Universitat Autònoma de Barcelona. I am white with short black hair and I'm wearing a black shirt. And this is our talk, a new framework to produce 360-degree subtitles in real time. Our vision statement and the motivation of this presentation is making VR accessible for all. To achieve this goal, it is essential to follow the born accessible principle, which encourages that accessibility must be considered at the design stage of any process. Immersive media technologies like virtual reality and 360 videos are increasingly present in our society, and its potential has put them in the spotlight of both the scientific community and the industry. VR can provide great opportunities not only in the entertainment sector, but also in communication, learning, arts, and culture. These technologies are gaining popularity due to the COVID-19 crisis, as they enable interactive, hyper personalized, and engaging experiences anytime and anywhere. The integration of subtitles in immersive environments is yet to be defined, standardized, and of course, challenges are multiple. According to Brown et al., subtitles should be generated in an immersive, engaging, emotive, and aesthetically pleasing way, always considering accessibility and usability. As you can imagine, producing and consuming immersive media content is not that easy. There are two basic accessibility tools: VR Subtitles Player and VR Subtitle Editors. On the one hand, there is a lack of media players supporting accessible services. The most of VR players do not focus on accessibility at all, and they had not been created departing from the user needs. Only the iMac player supports audio description, audio subtitles, and sign languages, along other features. This player was born inside an European Union project called iMac, which also developed a subtitle editor. This editor is now commercially available, and as you can see in the screen caption, it looks more or less like a traditional subtitle editor. The main innovation of the editor is the section inside the yellow box, called Angle in 360 Sphere. This allows to change the field of view angle using the navigation buttons in the video control area or moving the mouse with the left button over the video. Now, moving to this performance to the date, we would like to highlight the work done by the British Broadcasting Corporation, one of the first research organizations to design subtitles in immersive environments. These four types were designed. Number one, the evenly space, where subtitles are placed into the scene in three fixed positions. Number two, the follow head immediately, where subtitles are presented as a head-up display, always in front of you. Number three, the follow head with lag, where subtitles follow your gaze around, but only for larger head movements. If you look slightly left or right, it stays at the same place. And number four, appear in front then fixed, where each subtitle is placed in the scene in the direction you are looking at the time when it appears and remains fixed in that location until it disappears. These four types were tested, and users reported that while it was easy to locate the evenly spaced captions, the number one, they still prefer the headlock options. 2 years after, the iMac project conducted another research, and it was confirmed. Users prefer headlock captions. This second study also reveals the importance of guiding the users to the source of the caption. For example, where the person speaking is locating. To facilitate this requirement, location information was added to each subtitle. The iMac project designed and developed several guiding mechanisms, and test results show two preferred methods: the directional arrow and the radar. The third modality, a big arrow displayed in the center of the user's view, has also been implemented, just to demonstrate the method for implementing further user-defined guiding modalities. Well, these are the three default guide modalities demonstrated within the framework, and they are provided just as samples within the JavaScript code in order to allow the possibilities to test new ideas.
Our framework is based on a library of JavaScript functions, which can be both used and easily extended to provide subtitles within an immersive context. It's hard to test new ideas without a working prototype, and this provides the ability to rapidly implement new ideas, which has been shown to both promote understanding and help with problem solving. At the core of our framework is a 360-degree video player. This is implemented using 3.js, a JavaScript-based graphics library, which allows us to create a sphere, the inside of which is texture mapped using an HTML5 equirectangular video. The viewer is then positioned at the center, where looking around allows them to consume the correct rendering of the video from their perspective. Within the sphere, there are two main rendering containers, one aligned with the user's view, and the other is in fixed alignment with the world. This allows us to define geometric objects, such as a subtitle, aligned to either the user's headlocked position or fixed within the world, and therefore provides a base for all of the default modes we mentioned previously. The framework also provides an interface which can be bypassed if running a test, with specific options enabled. The interface includes multiple camera views of the world and a menu system, both of which can be easily extended to create new views and enable additional options enabled through the interface in order to allow contrasting and comparing of different methods. In an exploratory mode, the initial view provides a split screen rendering of the current environment with a whole world view on the left and the user's view on the right. A wireframe of all the components is initially shown in order to make it clear to understand what's currently being done. From here, the user can load a video either from the web server or directly from a local file. This allows for any format supported by the HTML5 video object. Also, the framework provides additional support for both Dash and HLS streams. Matching subtitle files are also loaded in our proprietary format, which includes the original TTML based information, but allows it to be extended with our additional information. And this includes scene and character information, as well as things like per frame positions for each character. We also have a built-in importer within the framework, which allows for existing subtitle files to be imported or new ones generated from text transcripts. In order to create extended subtitle files, the framework contains a basic subtitle editor, and this allows for the files to be edited, saved, whilst also being able to specify different positions for each character and these kinds of things. To establish the framework, we have implemented a few examples of what can be achieved. The first of these is to implement the responsive subtitle approach, allowing for traditional 30-character subtitles to be reblocked into alternate line lengths, following a set of basic rules, such as keeping paragraphs together and not continuing over a pause or change of speaker. This also provides the opportunity for different rendering styles, such as speech bubbles, although new styles can be created very easily using a CSS format. Finally, it was identified early on that there was a need to display multiple subtitles at once, if, for example, there were two people speaking concurrently, or if the viewer wanted to keep the subtitles longer and have more time to read them. Our framework was therefore extended to use a particle-based approach, where a manager is used to create and destroy new captions as required, either following the initial subtitle timing, adding a delay, or defining a maximum number of subtitles to be displayed. This also brought the challenge of collision detection, where our solution allows for the captions to be stacked to avoid occluding each other. In conclusion, immersive environments offer many new possibilities for subtitle presentation modes. In the past, technology did not allow for much personalization, and it was much more difficult to simulate the feeling of actually being there. Personalizing subtitles means creating different alternatives to the same product, focusing on features such as font size, color, position of subtitles, speed of reproduction, characters per line, etc. Experience gained in the iMac project showed that end users need to have real stimuli to test, and that in general users tend to prefer what they have already and are used to, rather than potential ideas. The new COVID-19 reality has also ousted the traditional face-to-face testing and has forced all communication-based industries to consider existing communication technology as alternative. Our silver lining is that with a framework such as this, online testing is now a reality. From the comfort of their own home and following all government health and safety regulations, end users can access test environments from any device.